What we're going to look at here is just a couple of ideas, alternative ways of finding the vertex or other pieces of information. So it's the same question we had before. Sketch the parabola y equals x squared plus 8x plus 12, and we're trying to get the information. This time I'm going to complete the square to solve it. But I'm going to complete the square slightly different to how we did it before, in that I'm not going to move terms to the other side. What I simply say to myself is this. I know that when I complete the square, I will always end up with x and then half the coefficient of x all squared. In this case, the coefficient of x is 8. So half the coefficient is 4. I know I'll end up with x plus 4 all squared. But then, if I was to expand that out, I'm not going to get 12. I'll get 16. Therefore, I go minus 4. Now, if you remember the work we did on shifting curves, I now know what the vertex is. Grouped with the x tells me the horizontal shift. So we know that it's shifted to negative 4 as for the x value. And then the number by itself tells me the vertical shift. So I know the vertex is negative 4, negative 4. So that can be a quick way, depending on the numbers of course, of finding the vertex by simply just completing the square. And then we can see it in that shifting idea. X-Intercepts, well, I can still solve it the traditional way, but now that I've got it as x plus 4 all squared minus 4 equals 0, I can say, oh, well, x plus 4 all squared is 4, so x plus 4 is plus or minus 2. I could do it that way. I probably wouldn't in reality, but it's an alternative. Write down the equation with roots 2 and 8 and vertex 5, 3. So again, here's another way of solving this particular question. I could have said it's going to factorize to be like this. Now, this is where we've got to be careful where we put that constant multiplier. It's not times the whole thing, it's only times the term with x in it. So the plus 3 stays by itself. The shift is because the vertex is going to 5, 3. So I know it's x minus 5 all squared. That's the horizontal shift. And plus 3, the vertical shift. But I group just the x part with that constant. And now I want to work out the constant. Well, we said the roots were 2 and 8. I only need one of those roots I can sub in. So when x is 2, y is 0, sub it in, and there it is, k is minus a third. And so there's my equation in the shifting form. And if you don't believe me, when we expand it all out, we do indeed get the same thing that we got before. That's the completing the square idea. Now I'm going to show you something which you might not have seen before. There's this thing called the discriminant. It might look familiar, b squared minus 4ac. Where have you seen that before? Yeah, it's in the quadratic formula. Commonly symbolized with a capital delta, so the triangle. But in Greek, that's the capital delta. There's a formula for the vertex. We know the vertex, the x value, is the axis of symmetry, minus b on 2a. The y value always turns out to be minus the discriminant on 4a. This has an advantage. If you've got one of those questions which says, find the maximum or the minimum of the function, I don't really care what the axis of symmetry is. I just want to know the y value. So I can say, I know the maximum or the minimum will always be minus the discriminant on 4a. The solutions, of course, is the quadratic formula, minus b plus or minus the square root of the discriminant over 2a. Notes. This tells us some other interesting things. If the discriminant is less than 0, then we know we haven't got any x-intercepts. Because back in our formula here, we'd be saying the square root of a negative number, and of course you can't find the square root of a negative number. If the discriminant turns out to be 0, then we know it just touches the x-axis. Again, if we subbed it into our formula, we'd go minus b plus or minus 0. And if it was greater than 0, now we know our parabola cuts it through a couple of times. And we'll talk a bit more about that idea in the discriminant later. But that's another thing the discriminant's useful for. So all right, same question, sketch x squared plus 8x plus 12. Now to find the vertex, I need my discriminant. B squared minus 4ac is 16. So there we go, there's my vertex. Minus b on 2a, minus the discriminant on 4a. Minus 4, minus 4. All right.